So there's a mistake that I want to make you aware of, which is that if you have a vertical asymptote or a singularity in the middle of your region, you have to be aware of that and split the integral up. So for instance, a good example here is f of x equals 1 over x squared. And what if we wanted to take the definite integral from -1 to 1 of 1 over x squared dx. I'm going to do it the wrong way first. I'm going to go ahead and tell you this is the wrong way. The wrong way is just to plow straight ahead and treat it as if it's the fundamental theorem of calculus problem. So the wrong way is just to do the antiderivative is -1 over x, and then plug in. So that you get -1 over 1 squared minus -1 over -1 squared. And so there's actually sorry, this shouldn't be squared. This is -1 over 1 minus 1 over -1. So there's a lot of minuses here, but the final answer that we would end up getting is just -1 over 1 minus 1 over 1, which would be -2. But that doesn't make any sense because this is clearly a positive area, and it's possibly an infinite positive area. So -2 can't work. That tells us this is an issue. And the problem is we can't use the fundamental theorem of calculus because this function is not continuous. Function, remember, the fundamental theorem of calculus absolutely requires that the function you're integrating be continuous on -1, 1. So the right way to do this is to split this up. This is the wrong way when you just plow straight ahead, and this is the right way when you split it up. So we're going to do what we did before. We're going to split this up as the definite integral from -1 to 0 of 1 over x squared dx plus the definite integral from 0 to 1 of 1 over x squared dx. And we're going to do these separately. And the thing is, if either one of these does not exist, then the whole thing doesn't exist. So we're going to do this process. We're going to do our limit as t approaches 0 from the right of the integral from t to 1 over x squared dx, which is going to then be this is negative x squared. So again, this is the limit as t approaches 0 from the right of -1 over 1 minus -1 over t. And this actually doesn't work because this becomes infinity as t approaches 0. So the right way tells us that this integral doesn't exist. So if this part of it doesn't exist or is infinite, then the whole thing can't exist because just this area by itself is infinite. So beware the mistake of using the fundamental theorem of calculus in a situation where it doesn't apply.